guys, this is Miss Paraso speaking. So today's video is on horizontal and vertical lines. So if you don't already have this in your table of contents and you haven't previously taken notes on this topic, first add to your table of contents horizontal and vertical lines, and then turn to the next open page to record these notes. Alright, now that you're ready, let's start to get this written down. First of all, a horizontal line. So you can remember horizontal by horizon, right? So the horizon looks like this. Remember, the sun sets over the horizon. So horizontal lines are this way, okay? And a horizontal line has a zero slope. So examples of horizontal lines are y equals 4 or y equals -2. Now, in contrast to that, the opposite would be a vertical line. So obviously then vertical is going to be up and down. So a vertical line has an undefined slope, meaning that it does not have a slope at all. It's undefined. So examples would be x equals -5 and x equals 3. Okay, so one way I remember the difference between them is I think about a person skiing. So if a person were to ski, let's say the ski hill looked like this, and the person was skiing on this hill. How fast would they be going? Well, I would say that they would be going a speed of 0, and that has a slope of 0. Now, if someone were to try to snow ski on this line, in contrast, that is not going to end well. So at that point, we're not even talking about how fast or slow they're going. We're just talking about that's undefined, because we're more talking about how many bones are going to break when they get to the bottom. All right, so next, we have to talk about graphing these. So here's an example. A horizontal line, when you graph it, for example, y equals 4, you would just go to the point on the graph where y equals 4. So that's 1, 2, 3, 4. And then you draw a line showing that y always equals 4. So it could be written in slope-intercept form, which would be y equals 0x plus 4. Okay, now, another example, y equals -2. So on the y-axis, I find -2, and then I draw a horizontal line showing that y always equals -2. In slope-intercept form, it would look like y equals 0x minus 2. So we don't usually write it in slope-intercept form. We just wanted to show you what it would look like and acknowledge that you could put in a 0x. Now, in contrast, here's vertical lines. So if it's x equals -5, you go over to -5. You can put a dot on the line here, and then you show that x always equals -5. If you were graphing x equals 3, you would go over to 1, 2, 3. You can put a dot on the line there. There's the x-intercept, and then every single time it's x equals 3. So you draw a vertical line showing that x always equals 3. Now these ones cannot be written in slope-intercept form. That's what SIF is. So these cannot be written in slope-intercept form because, first of all, it's not a function, and second of all, it doesn't have a slope. So how could we write it in slope-intercept form when it has no slope? In fact, most of the times it does not have a y-intercept. The only time it would have a y-intercept is if the whole thing was on y, but then it's just infinite amounts of intercepts, so we can't write it in slope-intercept form. Okay, so lastly, I want you to actually try a couple of these. So pause the video and graph y equals 7, identify the slope, and then graph x equals -5 and identify the slope. Okay, welcome back. If you're graphing y equals 7, remember that you go to 7 on the y-axis. So 1, 2, 3, 4, 5, 6, 7. Put a point, and then it is a horizontal line, and the slope equals 0. Okay, in contrast, graph x equals -5. I find x equals -5 on the x-axis. So I go back 5, plot a point, and now I have a vertical line like this. And what is my slope? It will be undefined. All right, thank you so much.